Well, it looks like Wednesday is going to be broadcast day. I've packed Jude off to her Tai Chi. She seems to get something out of it, so that's good. We've got a few things to get through today. Firstly, Handel's Hercules is being put on by the Canberra Choral Society on the 30th of May, and apparently it's an unmissable musical event. So says the Canberra Times, and Ian Warden would know. Has Christopher Richardson and the fabulous Christina Wilson, and it's a great story, and we're looking forward very much to playing that. We've also got something else to celebrate. I've got my first subscriber to this channel. A very dear friend has subscribed to Rose Resonance, so thank you very much, mate. It reminds me of another broadcaster in Australia, a guy called Philip Adams, who has sort of modelled himself over the years on Alistair Cookie, as Cookie Monster knew him, the Anglo-American broadcaster. And Philip, many years ago, decided to describe his audience as the listener, as if there was just one person sitting there next to their radio, listening to his dulcet tones, and well, there you go. All right, today's single malt Scotch whisky is Ardbegg's Uigeadail, or Oogie as we know it affectionately, non-chill filtered, very much cask strength, 54.2%. Ardbeg Distillery is on the south of Islay, in the Kildalton region, so ancient Celtic, site of an ancient Celtic church, and peaty and sherry casked, and we're generally getting through Jude's collection of unaged statement Scotch whiskies. Harriet's got a new bike, and she's allowed me to assemble it for her so that everything's tight and adjusted correctly. We're able to afford things like this because somewhere in the global village there's a sweatshop full of workers earning a pittance, but that's all going to change once we're able to print these things. What I just wanted to point out was this amazing technology here in the brakes. It's called Sure Stop. There's one brake lever. It pulls on these calipers here, but this particular shoe has a slide in it so that when the brake pad is applied, it slides forward through the force of the brake of the rim pulling on the pad, and it then pulls and adjusts the applies the front brake so that you don't go head over heels. And just beautiful, simple technology, but it illustrates where bike design hasn't changed much over the years, but just the final refinement is really taking place, and that the world is like a fine bottle of wine that's ready to be opened and sampled. In all seriousness, there might come a day when people say, Rowan, why didn't you shout it from the hilltops? I could do that, but the world's full of people broadcasting and publishing and a lot of noise, and it seems people are quite pleased with being able to discuss the difficulties that we face in the world. And isn't it wonderful it's just so complicated when it could be so simple? And what I prefer to do is just to quietly present some ideas, and if people like them, they can come and
learn more, but if they want to go their own way, that's fine, but I'm not going to push any of these ideas on them. Today we're just going to have a look at a book called Finding Zero by Uigeadail, who's a mathematician and physicist, and also likes an adventure. So he's very much into the history of science and has been on a lot of trips around the world, in this case discovering where the first zero seems to have emerged, which is in about the year 600 in Cambodia. And in fact he's found an ancient stone there with the year, a particular year around the year 600 that's been carved into that stone. And it shows that it predates by many hundreds of years any idea that zero first emerged in India or in Arabia on the way through to the west. And zero's a very important thing. We take it for granted these days, but it serves two purposes. It allows the number line to extend not just from real numbers, so counting apples, 1, 2, 3, and so on, but to extend into the negative numbers, which don't mean anything outside of mathematics, but they are invaluable in how the world works these days. And zero, of course, is between -1 and +1. And the other great innovation, of course, with zero is as a placeholder for powers of 10 notation. So there was only the Roman numerals up until the time of the invention of zero, which were in Babylonian base 60 system. All of these systems had very complicated ways of writing numbers. We now know that we can just put zeros in place for hundreds, thousands, 10,000s, etc. And makes school arithmetic the ease that it is. But zero has a very important philosophical basis in that when we look at the world that we live in and where it's all come from, the perennial philosophical problem, of course, is where did it all come from? So, we can look at the universe, imagine it's a sphere, and sit outside and say, well, here's God looking at the universe, and he's put the universe here, and where did he get that from? Well, he got it from a store over there. Basically, it's not going to cut it. God can't create something out of nothing, or can he? Well, we have to think about what nothing is, but we really need to get this universe to somehow emerge from nothingness. And the most obvious way to do that is to say, well, if you have nothing, you can split nothing in two, or divide nothing into -1 and +1, and you'll find parallels of this in a lot of modern physics, where it's been established that we live in a material world, but there's an antimatter world where the two annihilate each other, but they don't annihilate each other and become nothing, they become energy. So it's not really the sort of annihilation that I speak of here when I say if we take zero and split it into -1 and +1, we can sort of have one world that's +1 and one world that's -1, and the whole thing's come out of nothingness in the first place. Okay, how does that really work? So we've all heard of the Big Bang Theory, and it's fairly well established that the universe started from a very small size, but according to the general theory of relativity, the size that it starts from is unimaginably small. In fact, it's zero. It has no dimension in length, height, or width. And when you think about that in a regular sense, you think, well, there can't be anything existing there because it has no dimension. But dimensions themselves are quite possibly arbitrary, in that we all know that 3 dimensions are the most efficient way to get a world which has volume, which has existence. So do we need any more than that? Well, a lot of physicists will say we need 10 or 11 dimensions, and we start delving into the idea of the mathematical model. So what we're really trying to establish is what this universe is made out of. And we all know, or think we know, that the world's made out of atoms, and back in the early 1900s, when Rutherford started shooting alpha particles at gold foil, the nuclei, helium nuclei would bounce off the gold nuclei, and it looked as though there were little bits of dust and particles that were actually hitting into each other. But we've now realized, or we've always realized, but it's becoming more understood in a popular sense, that all of the physics that have been developed since those early days into atomic theory have been about mathematical models which allow us to describe and to accurately predict the behavior of these particles, but they don't really show us or tell us what these particles are actually made of. So what Immanuel Kant called der Ding an sich, the thing in itself, to know what actually a quark is or an electron is. And Aristotle said all is number, and what we will find as we go through is that perhaps number is indeed exactly what we're looking for. Anyway, see you next time.